Welcome to another episode of Data Analytics Chat. I'm Ben Parker, data recruiter and podcast host, looking to share knowledge and insights for the data community. Today, I'm excited to welcome Shashi Kumar, Head of Data Engineering and Analytics at Hearst. In this episode, we'll explore his career journey, how he got started, pivotal moments that shaped his path, and a look at how the role of data engineering is evolving in the era of generative AI. Shashi, welcome to the podcast.
Thanks for having me, Ben. It is a pleasure.
I'm looking forward to this. So let's start off. Can you share your career journey?
Yep. My journey into the world of data began in a role that's pretty foundational to the field. As a database administrator from the very start, I was captivated by the intricacies of managing and optimizing the data systems. The complexity of the data architecture, ensuring data was accessible, secure, and scalable, these were the challenges that sparked my interest and drove me to dive deeper. It gave me a strong technical foundation and solid understanding of the underlying infrastructure that powers everything in data engineering. As I honed my skills, I started to evolve in my career. I transitioned from database administration into data engineering and then into data architecture, where I was able to start shaping the data ecosystem on a larger scale. As I continued to grow, I moved into solution architecture, where I began focusing on aligning technology solutions with business needs. Along the way, I also led the Center of Excellence for Snowflake, which gave me a unique opportunity not only become an expert in cutting edge cloud data platform, but also guiding organizations in how to leverage Snowflake to its fullest potential. This progression allowed me to view data from a much broader perspective, not just as a technical asset, but as a strategic asset that could unlock business value. I saw data as something more than just the raw information. It was a resource that could drive efficiency, innovation, and growth. The journey didn't stop there. I moved into leadership roles where I could shape data strategies at a higher level. As Senior Director of Data Science Engineering, I became increasingly focused on data science, AML adoption, and scaling these technologies with organization. I truly believe that AI and machine learning are transformative in a way business operates, and I wanted to be at the forefront of that change. For me, it was never just about building system. It was about creating ecosystems where data could be the driving force behind business innovation and monetization. Throughout my career, I always been driven by a few key things: a passion for solving complex problems, deep curiosity about how things work, and a vision for how data can be leveraged, not just to improve operations, but to create an entirely new opportunity for business, whether it's through scalable data ecosystem, driving AML adoption, or transforming data into actionable insight. My journey has always been about using data to fuel business sources, ultimately shape the future of how organizations make decisions. And as I continue on this path, I'm passionate as ever about the incredible potential that data holds, both in terms of innovation and in driving real world outcomes.
Brilliant, fantastic journey. So I guess for listeners, there's going to be people that are looking to make the progression into leadership. At what point did you realise you wanted to go pursue the leadership track?
Can you come again?
At what point did you realise you wanted to pursue a leadership role?
That was already as I started working as a head of Center of Excellence for Snowflake, I was already playing that leadership role. Even in the JP Morgan Chase, I was already playing that. It was a transition phase. It's nothing that I got promoted to that, but I was already playing that leadership role when I moved to JP Morgan Chase as a VP of architecture. So we have to build a design the systems that is really for the payroll and mortgage banking system. So I already had transitioned into that leadership role. It was not a promotion kind of thing. So it happened in phases.
Okay, so is it just like a natural progression?
Yes, it is.
Okay, brilliant. And then what were the biggest challenges moving from, I guess, an IC role to a leadership position?
Some of the challenges there is like when you move to the leadership role, your focus more will be on the strategy point of it, and also you'll be um looking after the people management. That's where like your focus on the technology would be a little bit less, but I would I would say like people management would be a little bit of challenging people when you move from a individual contributor to a leadership role.
Brilliant. I hear that a lot, and I think it is a big challenge for a lot of people. Okay,
Yeah,
then looking back, what were there? I mean, were there key moments that shaped your career?
yeah, that's a good question. My career has been shaped by several defining moments, each pushing me to grow, adapt, and expand my perspective on the power of data. The first key moment was the early years of my career when I worked as a database administrator. It was highly technical and challenging role, but it gave me a strong foundation in database management, performance optimization, and data integrity. I realized that data was more than just storage; it was the backbone of the business decision making. And another pivotal role was stepping into the role of as an VP of architecture at JP Morgan Chase, where I was responsible for designing and building large scale data warehouses for card services, mortgage banking, and HR. One of the most high stake responsibility was ensuring payroll accuracy. Every 2 weeks, we processed paychecks for thousands of employees, and there was zero room for error. That experience reinforced the importance of precision, reliability, and accountability in data systems. The next major milestone was leading cloud migration initiatives. As the organization shifted from on-premise infrastructure to cloud platform, I led teams of solution architects and data engineers to develop accelerators for migrating workflows to AWS and Snowflake. The transition not only optimized performance but also resulted in over 20% cost savings, not only in the infrastructure but also from the licensing cost, demonstrating the tangible business impact of well executed data strategies. Following the cloud migration phase, I began leveraging the data science and machine learning to drive deeper insights and automation across the organization by integrating predictive analytics, personalization, and AI driven decision making. We are able to optimize marketing campaigns, enhance customer engagement, and improve operational efficiency. This shift helped the organization unlock new revenue streams, improved user experiences, and gain a competitive edge in an increasingly data driven world. More recently, a defining moment has been working at the intersection of AI and ML and data driven innovations. As business increasingly look to monetize data and leverage AI for a competitive advantage, I have focused on building scalable data ecosystem that enable advanced analytics and intelligent decision making. So, looking back, each of these moments shaped my approach to data, starting from a technical foundation, evolving into strategic architecture, now driving business transformation through AI and cloud native solutions. The ability to continuously adapt, embrace emerging technologies, and leverage data as strategic asset has been the common thread throughout my career.
I think if you look back, like cloud was massive, which it still is, and now AI is a game changer, isn't it? We've gone through quite a lot recently, haven't we? Yeah.
Yes, yes. It's a game changer. Yeah.
Wicked. So have you ever faced a major career setback?
Mm. Can you come again? Sorry, I get that.
Have you ever faced a major career setback?
Yes, I did. One of the biggest setbacks in my career was actually leaving JP Morgan Chase. I was in a well established leadership role, deeply involved in large scale data initiatives, and had built a strong foundation within the organization. Looking back, stepping away from the stability and rewarding position I had there felt like a major risk. But here's the thing, right? Sometimes in your career, you have to take those calculated risks to explore new opportunities and push your own boundaries. In the moment, it definitely felt like a setback, but over time, I realized it was a turning point that ultimately shaped my leadership journey. It forced me to quickly adapt, build resilience, and importantly, expand my expertise beyond financial services and into entirely new industries. And that was a huge shift for me. Till then, all my experience was in financial industries, working for Citigroup, Merrill Lynch, and JP Morgan Chase. Stepping outside of what I knew and developing a whole new perspective was a different experience. And there are like risk and growth go hand in hand. While stability is valuable, but the real growth often comes from stepping out of your comfort zone. So every challenge is present an opportunity to learn, innovate, and evolve. So even though the transition felt very tough, it set the stage for growth that I wouldn't have experienced otherwise.
Yeah, no, I love that. I think, especially when challenges come, I think like when it's challenging or you're going through that tough times, like I think it's quite easy your brain to tell you to quit or stop. But that's when you gain strength, I think, is when you push through the tough times and get through, and then you learn and grow as an individual.
Yep, yep. That's what it's always the long term vision that matters. We should not be focused on the immediate challenges or setbacks, but ultimately what's important to evaluate the decision based on the long term impact.
Yeah,
And you should be
that's,
ready for the short term discomfort.
yeah, cool, cool. So what skills have helped you progress into leadership, do you think?
Hmm. When I think about what helped me stand out in the data industry, especially as I've stepped into leadership roles, it really comes down to a mix of technical depth, business thinking, and people skills. First, I've always made it a point to approach data with a strategic mindset. For me, it's never been just about pipelines or dashboards. It's about using data to drive real business value, whether that means unlocking new revenue streams, cutting down operational inefficiency, or gaining a competitive edge. I try to keep that business lens front and center in every initiative I led. On the technical side, I have built a solid foundation across data engineering, database management, and cloud platforms that help me stay ahead through big transition, like moving from traditional ETL system to modern cloud native architecture or integrating AI into analytics workflows. I always try to stay ahead of the curve. When it comes to the new technology, I would dive into emerging tech stacks, explore what's out there, and figure out how we could leverage those technologies in our projects to stay competitive and innovative. The key has been adaptability, being able to evolve with the tech while keeping teams and stakeholders aligned. I also bring a strong problem solving mindset to the table. The data world moves fast. There are always new challenges. What helped me stand out is seeing those challenges as opportunities to innovate. Whether it is building the accelerators to speed up cloud migration, optimizing cost models, or experimenting with GenAI to extract the deeper insight, I genuinely enjoyed turning complex problem into elegant, scalable solutions. And when it comes to the leadership and team building, I also been huge on that. I've been very intentional about building high-performing collaborative teams and creating an environment where continuous learning is part of the culture. Giving people the right tools, clear goals, and freedom to grow has been key to the driving transformation. And lastly, I am deeply committed to the data governance and ethics part of it. As data becomes more central to decision making and as Gen AI systems become more powerful, trust becomes non negotiable. I always prioritize building systems that are not just scalable, but responsible and compliant. At the end of the day, I think what really helped me stand out is being able to bridge the gap between technology and business.
Brilliant. And then obviously, like, I mean, your field is ultra technical. How have you developed like the skills? I guess firstly on a technical basis, and then I guess secondly gaining them soft skills like communication, stakeholder management. How have you learned them throughout your career?
Technology part of it definitely like there are a lot of resources now available where you can go and learn those skills. So, and also like I did go to like General Assembly for the data science in 2018. Those are the new things that the data science was the emerging technology then. So I went and attended those courses, and at the one more thing, what I do from beginning of my career is like I take certifications. So when you take certifications, you really get in depth of the subject and try to learn more about it and try to master that subject. So I'm certified in Oracle. Uh, I'm certified in AWS, certified solution architecture, Snowflake, Snowpro, Python. There are like 15 to 20 certification that I have, which I have not put on the resume. It will take a lot of space. So that's how I keep learning, like where I really can master the skills. And then in the new world, one more thing, what I do, like we have a safe sandbox that we have created. That's an environment where we can experiment things in safe environment and then build fast and then fail fast and learn fast. That's the approach.
Brilliant. And then what about on the soft skills?
Soft skills, it's all as you communicate with your teams, as you learn from your um, mm, peers and your leadership. That's where you can pick up those soft skills. So it's always presents an opportunity. You don't have to learn from the senior people. Even there are opportunity when I learned from a junior intern as well, where they came with a very good presentation skills and how they communicate and all those things. So I look for every opportunity where I can learn from anybody so that will improvise me better, Shashi.
Amazing. I love that. It's good. Oh, every day is learning day. Brilliant. So let's dig into obviously the data topic. So how has the emergence of generative AI changed the core responsibilities of data engineers?
Very good question. The role of data engineering is going through one of its biggest shifts yet, and Gen AI is a huge reason for that. Traditionally, data engineers were focused on what I would call the foundational layer, moving data from point A to B, setting up ETL pipelines, making sure data was clean, reliable, and queryable. The goal was to feed dashboards or support business intelligence. But with the rise of large language models and Gen AI, the foundation is no longer enough. We are now seeing a whole new layer of responsibility emerge. Data engineers are being asked to curate not just any data, but context rich, semantically meaningful data that can actually power LLMs. These models don't just rely on numbers in rows, they thrive on unstructured content like PDFs, transcripts, logs, emails, or web content. So suddenly the skills like text pre-processing, embedding generation, OCR, chunking, and metadata tagging, things that used to sit more with the NLP researchers, are becoming a core to the data engineering role. And another big shift is around real-time data. LLMs in production, right? Thinking RAG-based chatbots or AI co-pilots need fresh, low-latency data pipelines. So engineers are building systems that feed directly into the vector databases, sometimes using streaming platforms like Kafka or Flink. This goes way beyond batch ETL processing. It's about delivering dynamic knowledge to the model exactly when it needs it. And this is where the collaboration becomes key. We are seeing data engineers, ML engineers, and domain experts working in tight knit pods. They are co designing the flow of data from source all the way to the inference. For example, deciding how documents should be chunked for better retrieval or how metadata should be structured so that an LLM can actually reason over it. It's far more interdisciplinary role now. Also, if you're talking about governance, also, right, that has become a top priority. Let's face that, right? LLMs can memorize and regulate this sensitive data. So, data engineers are also becoming responsible for automated PI redaction. So, access control, data lineage, and compliance checks. Tools like Data Hub and open metadata are being used not just for documentation, but for ensuring AI systems are auditable, explainable, and compliant. And to be honest, this makes the role a lot more strategic. It's no longer just about building the pipelines. It's about enabling intelligent system that are trustworthy, scalable, adaptable to the evolving needs of the Gen AI. So, in short, data engineers are stepping into the spotlight now. They're no longer just supporting AI from behind the scenes. They're shaping how AI learns what it knows and how safely it operates.
It's just, I mean, over the last since the LLM boom, does feel like
Yes.
data management, data engineering is becoming so important now for businesses. Like, there's a lot more investment. I think there's a lot more awareness that look, we need to get your data in order to build these models.
I agree with you. 100% agree with you.
Right. So then, what new skills or tools are becoming essential for data engineers to support scalable and efficient Gen AI initiatives?
Yeah, very good question. The data engineering landscape is evolving really fast. So let's start with the tools. The modern data stack continues to dominate because it delivers agility, scalability, and tighter collaboration between data analytics and AI teams. So if I want to break it down from the data warehousing perspective, there are platforms like software as service Snowflake, BigQuery, Databricks are leading the way thanks to their elastic compute, cross cloud capabilities, and tight ecosystem integrations critical for both traditional analytics and Gen AI workloads. And from the transformation and modeling perspective, I think the DBT, the data build tool, has become the gold standard for SQL based transformation. It brings the software engineering practices like version control, testing, and modularization into analytics space, making pipelines more reliable and easier to debug. I recently had a demo with the DBT team. They walked me through how it is a AI data engineer. So you can provide inputs to ask the DBT tool to build the pipelines for you and data lake houses, right? The technologies like Apache Iceberg and Delta Lake are bridging the gap between the data lakes and warehouses. They are helping teams manage structured, semi-structured, and unstructured data more efficiently, which is exactly what Gen AI models require. When it comes to the streaming part of it, um, I think nothing new. Like we already have Kafka, Fling, Confluent, which are enabling event-driven architectures that can support the real-time feature pipelines and anomaly detection and interactive Gen AI apps. And when it comes to orchestration, previously we used to have like Tidal, Control M, and all those things. Now the with more growing more complexity, orchestration like Airflow, Daxters are crucial. They provide better observability, scheduling, dependency management, ensuring end-to-end workflows stay healthy and maintainable. And from the visualization and BI perspective, we have a legacy tools like Power BI, Tableau. Uh, they are rising interest in the modern AI integrated platforms. Um, ThoughtSpot. I'm very impressed with the ThoughtSpot and natural language BI tools that support conversational querying, making insights more accessible to non-technical users. And when it comes to the skills and platformization for Gen AI, I think it's the vector databases like Pinecone that's important. And from the ML ops and observability, probably we need to be more fluent in monitoring data drift, quality checks, and integrating with ML pipelines.
Interesting. It's yeah, a lot of movement happening, and yeah, a lot. I don't know there's many tools on the market now. It's okay, applying the right ones. So you touched on collaboration. How can data engineering teams align more closely with the data science and ML teams to ensure that high quality data for the LLM applications?
Okay. Hmm. For LLMs to deliver real business value, the data engineering teams must work in lockstep with the data science and ML teams because the quality of the input data directly shapes the intelligence of the model output. This alignment is no longer optional. Now it is foundational. It starts with establishing a shared understanding of the data requirements. LLMs are hypersensitive to data quality, structure, and semantic richness. That means that data engineers and data scientists need to sit down regularly. Joint planning sessions are key to map out what kinds of data are needed: unstructured text, document embeddings, prompt tuning data sets, and more. Shared data contracts and document standards help ensure expectation around schema, freshness, and completeness are aligned from day one. Both teams should operate from a unified metadata and lineage system. When model performance degrades, it's often a data issue, but you can't fix it what you can't trace. Tools like Data Hub or Open Metadata allow both engineers and data scientists to see the full lineage from raw ingestion all the way to the features and labels used in the training. That visibility builds trust, speeds up the debugging when things go wrong. LLMs consume very different data than traditional models. They rely heavily on the unstructured, long form content like documents, emails, and logs. So, data engineers must build scalable pipelines that go far beyond rows and columns. Pipelines that handle OCR, text extraction, NLP preprocessing like tokenization, deduplication, and chunking. The ML team should be involved early in the design to make sure no important context is lost in the transformation process. There has to be a strong focus on data quality monitoring and feedback loops. LLMs are incredibly sensitive to noise, drift, and subtle schema changes. Tools like Monte Carlo should be embedded directly into the pipeline for real time validation. Just as importantly, there should be a structured process for ML teams to report model issues so data engineers can do root cause analysis and quickly resolve problems before they affect other workflows. None of these workflows without a culture of collaboration, silos kill Gen AI projects. To break them down, teams should be co located in cross functional pods where data engineers, ML engineers, and data scientists all work together towards shared outcomes. Even temporary team members' rotation across functional can go a long way in fostering empathy and deeper technical understanding. And lastly, team need to plan for long-term data governance and privacy, especially because LLMs can inadvertently memorize this sensitive information. Data engineering and ML teams must partner to define PI, redaction pipelines, retention policies, and privacy strategies. In some cases, techniques like differential privacy or synthetic data generation may be needed to safely train models without risking compliance or user trust.
Brilliant. And then, so is it more important with the like to run agile sprints then now to notice errors and I guess hallucinations and that sort of thing?
Yes. Yep. So to build truly impactful LM application, what I'm trying to say is it's not like it's about co-owning the model outcomes. That means that tighter collaboration, shared responsibility for data quality pipelines is required now.
Okay, interesting. And then, in what ways is the modern like data architectures supporting or hindering the successful deployment of these Gen AI solutions? Sorry.
Yeah, absolutely. Modern data architecture is both a catalyst and a constraint when it comes to deploying generative AI solution. It's a bit of a double-edged sword. Starting with, I can start with the positives. Today's architecture are more cloud native, decoupled, and modular, which is a huge advantage. We now use data lakes like Delta Lake, Apache Iceberg, that supports all kinds of data, structured, semi-structured, and unstructured. That flexibility is exactly what LLM needs for training and fine-tuning. Elastic compute, that is another enabler, which cloud services we can scale up processing power on demand, like Snowflake, the capability that Snowflake provides, whether we are running intensive training jobs or fine-tuning models on smaller data sets. This has massively lowered the entry barrier for deploying Gen AI. So modern architecture also supports a broader range of data inputs like text, audio, PDFs, images, and that's critical. Generative AI thrives on diverse multimodal data. Integration with the vector databases like Pinecone are now common, which enables RAG. That's where the Gen AI really starts to become useful in the business, answering complex queries grounded in actual enterprise data. There is also a cultural and architectural shift happening with the adoption of data mesh and domain oriented data ownership. This model pushes responsibility for data quality to the teams closest to the source, resulting in better curated and more context rich data sets. That's a big deal because LLMs are only as good as the context and quality of the data they see. These metadata driven pipelines add another layer of trust and transparency. With data catalogs, lineage tracking, observability tools, we can trace where data comes from, how it transforms, and what it feeds. That visibility is crucial when these pipelines are powering GenAI outputs that might be used in high stake decisions. On the tooling front, platforms like Snowflake, I already mentioned, right? Snowflake, Databricks, and BigQuery are now offering the native support for LLM and ML workflows. This reduces the friction between data engineering, data science, and AI development, bringing everything closer to a unified end-to-end Gen AI platform. So, but despite these advances, modern architecture still introduces some real challenges for the Gen AI. To start with, first off is the data silos haven't gone away. Even with modern data platforms, information often remains fragmented across business units, across clouds or legacy systems. For Gen AI to work well, especially in use cases like enterprise search or knowledge assistant, it needs access to unified contextual data, and that's still hard to achieve. Then there is latency. Many architectures are still batch oriented at their core. That's fine for analytics, but not for Gen AI. Use cases that demand low latency and feedback, like interactive chatbots, real-time summarization, or document Q&A systems. Moving towards streaming and event-driven architecture is still a work in progress. And talking about data governance, which is another pain point, most frameworks are optimized for structured data like rows in a table, but GenAI often relies on unstructured data, documents, images, free-form text. Without proper governance, this data can be misclassified, lack access controls, or even violate compliance rules like GDPR or HIPAA compliance. So, and tool sprawl is also a growing problem. You got ETL pipelines, you have ML ops platforms, vector databases, LLM orchestration tool, observability layers, and more. While each tool adds value, stitching them together requires significant efforts and expertise. This overhead can slow down the development and make it harder to experiment at the speed Gen AI demands. Finally, the lack of a semantic layer is a big limitation. Gen AI models are great at generating text, but without a strong semantic understanding of your data through embeddings, entity resolution, or contextual tagging, they often miss the mark. They might alternate pull the wrong facts or fail to adapt to a specific domain.
Yeah, good, good. And it's interesting to hear. So then, what strategic investments should organizations be making in their data engineering capabilities for the rapid Gen AI adoption?
Yeah, modern data have laid a strong foundation for Gen AI, but they weren't designed with it in the mind. So they need to. The big unlock will come when organizations evolve their architecture to treat unstructured, contextual, and real-time data as their first-class citizens. That's when Gen AI will go from the experimental to truly enterprise grade.
Yeah, no, I think it's definitely, I think, more of a learning curve, isn't it? For businesses that
There is a
investment
lot,
need.
yes.
Yeah. Okay, brilliant. Cool. Well, I really appreciate your time. Some really good insights into, I guess, the new era of data engineering and a great look into your career. So, yeah, obviously, congratulations on your career today as well. And it's been a pleasure having you on the podcast, Shashi.
Thank you. Thanks, Ben. Thanks for having me.